Right now we're going to go through chapter 4, number 41, and we're given a figure, and we said it tells us that a ball is thrown leftward from the left edge of the roof at height h above the ground. The ball hits the ground 1.5 seconds later at a distance 25 meters from the building at an angle 60 degrees with a horizontal. So we have to find h, the height of the building, and then we have to find the magnitude and angle of the velocity at which the ball is thrown, and of course that's from this point on the building. And is that angle above or below the horizontal? They give us a hint right here that one way is to reverse the motion as if on videotape, like we watch videotapes anymore. So pretending like this is the beginning and that's the end. And by the way, the reason why they don't draw it over here is because we don't know if it's going to go up and over or just down right there, like as if the whole projectile was a little bit further out that way. But anyway, I'm going to try to do this problem without pretending like we're going in reverse motion. We're going to go in forward motion, and I'll show you how that can be done. And so, but I'll discuss the backwards motion as well. So I've written out everything we know. We want to know the height. We know our time. We know our x distance. We know our final theta right there. And we know that our velocity in the x direction is this v final cosine theta, and that's going to be a constant x velocity the whole time. And our y final velocity is this v final sine theta, and that's going to be going in the negative direction. So we'll account for that when needed. So here's kind of our toolbox again. Here are all our kinematic equations. And we, as always, are going to look at what we have, look at what we want to get, and kind of try to figure out what's going on. And so, of course, we're trying to figure out the height, but we're also trying to figure out the magnitude of our initial velocity, which means we need to go to the x velocity and the y velocity and the angle. And then, so initial angle. And I'm not going to draw that because, again, I don't know if it's above the horizontal or below the horizontal, but we'll figure it out. And so I'm just going to start with this equation right here, the x equals x naught plus v naught t plus 1/2 at squared, because I know this distance right here. And so that seems promising. I might be able to figure out something useful. So my final x is at 25 meters. My initial is going to be right here. I'm having this direction be my positive x direction because that's the direction of my motion. Plus my initial x velocity. Now we know that that x velocity is going to be this, whatever that final is, times cosine theta times our time, which is 1.5 seconds, plus 1/2 times my x acceleration, which as always is 0, times my time squared. And so we know our theta. This theta is 60 degrees. And so I will have 25 over, my time is 1.5, cosine 60 equals this v final right here. And so I can work this out. It turns out to be 33.3 meters per second. And the great news from this is that I can figure out what my Vx is and what my Vy final is. So I'll go ahead and do that because it's the more things you figure out, the more you're able to figure out. So Vx, as we know, is V final cosine theta. So that's 33.3 times cosine of 60. So that will equal 16.6 meters per second. My Vy final, and again, this is right here at the end because we're throwing it initially off the side of the building. That is going to be my v final, sine theta. So that's 33.3 sine 60. And so that will equal it's going to be 28.8675 meters per second. Since we're going down, I know that this is a negative velocity. Technically, this 33.3 should also be negative, but we're just considering the directions here. So I have my Vy final right there. And so, again, we're just piecing this together. So I want to try to figure out what else I can figure out. And I know that I have this equation right here, v equals v naught plus at. And since I now have my y final velocity and I know my acceleration in the y direction and I know my time, I can use this to figure out what my initial y velocity is. So I have negative 28.86 28.8675, that's my final y velocity, equals v initial y plus negative 9.8 times my time of 1.5 seconds. And so if we work this out, this is negative 14.7. So I add that to my negative 28.86, and I find out that my v initial y equals negative 14.1675 meters per second. So the great news here is that we now know our x velocity the whole time. So I'm going to redraw this little piece over here. So here's the edge of my building. I have my Vx, which equals 16.6, and I have my Vy, which is a downward 14.16. And this is just the edge of my building right there. And so with these pieces of information, I'm able to figure out answers to B, C, and D. And then we'll come back and we'll figure out answer to part A. So if I want to know the magnitude of my velocity at which the ball is thrown, all I have to do is use the Pythagorean theorem here to figure out what this actual velocity is. Sorry, that was not to scale. Let's make that better to scale. There we go. So my V initial magnitude is going to equal the square root of 16.6 squared plus 14.16 squared. And if we work this out, that will equal 21.9 meters per second. So here is the answer to part B. And then now I'm going to figure out this angle. It says relative to the horizontal. I'll redraw my 14.16 right there. And so I can see that I can just use tangent of theta. So let's do that right here. Tangent of theta equals 14.16 over 16.6. And I find out this theta is 40.4 degrees. And so that is the answer to part C. And I already know that this angle is below the horizontal because I already solved for my negative y velocity. So our answer to part D will be below the horizontal. So now all I need to do here is actually figure out what we initially set out to do, which is to solve for the height. And so I go back over here and I can use a variety of different equations to solve. I could use this first one because that has a height in there, or I could use this third one that I've written here because that also has a change in height. I'm going to choose to use this one, but but either would work because we know our initial y velocity here. We know everything for both equations. So here we go. V squared equals V naught squared plus 2a delta y. So this is my final y velocity. That's right here. 28.8675 squared equals my initial y velocity, which is negative, but it's going to be squared. So both of them are negative. But again, since they're squared, it doesn't matter mathematically. 1675 squared plus 2 times negative 9.8 times our delta y, which is what we're solving for. So once we solve for this, we find out that our height it'll be a negative height that we're given here, but because I chose that to be our downward direction, but the actual height is a positive 32.27 meters, which is the answer to part A. So now we've solved for everything. And just a quick note, the reason why they gave the hint about reversing the motion is because when we figured out our final y velocity right here, if we would have pretended like that was our initial y velocity, then we could have just straight away used this equation to solve for our height. And that's what I did over here on these homework solutions. So I used this, and here's my initial y velocity, which is actually final. And then you can plug everything in and you find out what your height is. And the reason why that works is because projectile motion is symmetric, and so it works in both ways. And so we have done it. The end.